I'm coming to 11.2 transformation and translation of parabolas. In this session, we're gonna learn about translation of parabolas. So we um, compare to the graph of y equals to x squared, and the graph of y equal to x squared plus k is shifted vertically k unit, and the graph of y equal to x minus h, everything square, is shifted horizontal 8 unit. Um, so what does that mean? Let's do an example. Compared to the graph of y square. So let me let here is the graph, right? So if I say here is y equal to x squared, then the graph of y equal to x squared minus 4 is shifted downward 4 unit. So 1, 2, 3, 4. So here is going to be the graph of. So we have y. This one is y equal to x squared minus 4, right? So you shifted downward 4 unit to get the y equals to x squared minus 4. For the one that x minus 4, everything square, you wanna shift it to the right 4 unit. So 1, 2, 3, 4. Okay, and then you have a new one like this. Okay, so that is y equal to x minus 4, everything square. Yep. So and in the other side you have like x plus 4 square, everything square is going to be shifted to the left 4 unit from the original one. Okay, so for the vertex form, we want to learn about the vertex form also. So the vertex form of the equation of a parabola with vertex hk is y equal to a minus h. Y equal to a multiplied by x minus h squared, and then plus k. In here, remember that a is not equal to 0. Okay. And also a is constant. If a is greater than 0, then the parabola is upward, and if a is less than 0, then parabola downward. For example, the graph of y equal to 3x squared, x plus 2, everything square here, minus 7, has a vertex of 2, negative 2, and negative 7. Okay, so and it's open upward because a in here is 3, which is greater than 0. Okay, so we want to learn about completing the square method. In order to complete the square to obtain the vertex form, we're going to add and subtract b over 2 squared on the right side of the equation. Y equals to x squared plus b x plus c. Then factor the perfect square trinomial. So so for example, in here I have if y equal to x squared plus 10x minus 3, we're gonna add and subtract b over 2 squared, which is 10 over 2 squared, right? See that? Equal to 15, sorry, equal to 25 on the right side, of the equation. Okay, so you can see over here, what I do is I adding 25 and then I subtract 25. See that? So when I adding 25, I can make, you know, x squared plus 10x plus 25 over here. This one become just x plus 5 squared. And then I minus with 28 at k. So, and then I have the vertex in here gonna be -5 minus 28. Okay, so let's we go ahead and talk about the graph of y equal to ax squared. The graph of y equal to ax squared is a parabola with the following characteristic. So firstly, vertex always 0, 0. And the axis of the symmetry is also just x equals 0. And is open upward if we have a greater than 0 and downward if a less than 0. It is wider than the graph of y equals to x squared if a is the absolute value of a is in between 0 and 1. So it could be like a could be in 0 and in between -1 to 0, or a in between 0 and 1. That will make the graph wider. Okay, but it will be narrower if the graph with than the graph of y equals to x squared if a is greater than 1 or less than -1. So in here I'm gonna write it said absolute value a greater than 1. So let's do some example. We're gonna try to compare the graph of g of x equal to -3x squared to the graph of x squared, and then graph both functions in the same xy plane. All right, so so now seen in here I have a, you can see that a in here is okay, so I'm gonna say that g firstly I'm gonna say both parabola, right? Parabola. Right. Firstly, I want to say that, and then but g of x equal to -3x squared. That means a equals to -3, which is less than 0. So I will say that g of x is open downward. And okay, and you have absolute value of a is equal to 3, which is greater than 1. So we're gonna say again g of x is narrower than y equal to x squared. So I will you know what, I will grab it. Okay, so let me make it bigger a little so I can grab it better. So here, if I say the graph of y equal to x squared, like this, okay, y equal to x squared, like this, right? You see that? Then I can have y equal to 3x, negative 3x squared will be narrower and downward, right? Y equal to negative 3x squared. Right, see that? Okay. Both of them have to go through 0, 0 as a vertex, right? Okay, so let's move to example number 2. Translating the y equal to, translating the graph y equal to x squared. Okay, so we have y, graph the equation and identify the vertex and compare this graph to y equal to x squared. Okay, so for this problem a, x squared plus 2, I can say it is similar with the graph of y equal to x squared. But it is shifted upward 2 units. Okay, and because at this one in the format y equals to x squared plus h, right? You see that? So we shift upward h unit is 2 units, right? You see that? So let me have the graph. You know what? Let's move down this one a little bit. Okay. So here I have the graph of, oh, come on. Y equal to x squared is here, right? I try to make it more symmetry. Okay, so look better. As 0, 0 was a vertex of y equals x squared. But if you shifted it upward 2 units, so 1, 2 here, right? Then the new graph, will be like this. Oops. Okay. So this one is y equal to x squared plus h. And the vertex was 0 and 2. So say vertex of y equal to x squared plus 2 is at 0 and 2. Okay. So let's move to B. Y equals to x plus 3 square, right? So look like we have this one, right? This one. So down. Okay. So I'm gonna say y equal to let's see, x minus 8 squared. Right. So that's and in here, I don't even need to write it down. I'm just gonna say and have the graphic here. Oh, the graphic. So I'm gonna move to the left. Right, I'll move to the left. So the original one was here. Y equal to x squared. So everyone will think if I plus 3, okay, x plus 3, every square. So it's like, it's like changing the input x over here. You want to move to the left, not move to the right. Someone will think, oh, adding that move to the right. No, that is move to the left. So 1, 2, 3, 3 units. 3 units. Oh, come on. Move to the left. 3 units. And now you have new vertex was here as -3 and 0. And then you have new graph. Look like the old one, but just gonna shift to the left 3 units. See that? That is y equal to x plus 3 squared. Okay, so for this one, say it similar with y equal to x squared, but is shifted left 3 units. Okay, vertex is -3, 0. Okay, now move to the C. You have to have more. Okay. For this problem, it's a little bit complicated, but you're gonna think about uh, you must start with thinking as uh, y equal to a big X squared minus 3, something like that, right? And then from there, you're gonna just shift to the right 2 units. Okay, so basically this combination between shift right and shift down, right? So, this guy, for this term, you're gonna say shift shifted right, and this part over here, or you're gonna just say this part over here, will tell you that shift down downward. Okay, so let's say is similar with similar with y equals to x squared, but is shifted right 2 units and downward 3 units. Vertex is, okay, so let's see what the vertex. Okay, so I'm gonna draw the original one first, right? Original one first was here. Oh, come on, man. Here's a original one was y equal to x squared, right? And then from this original one, I move to the right 2 units. So 1, 2, right? I move to 2 units right here. And then I move down 3 units. So move this to here. So I have vertex is as 2 and -3. And the graph will be look like this. There you go. and that is y equal to x minus 2 squared minus 3. Right, see that? So this is like a rough graph for you guys to, you know, to using the translation way, but anyway, that's real. Anyway, if you use by the way that t tables, you can grab it easily, right? You can still grab it easily. Okay. So let's move to example number 3, graphing parabolas in vertex form. Okay. So compare the graph f y equal to fx to the graph y equal to x squared, and then sketch the graph of y equal to fx and y equal to x squared in the same xy plane. So I have a in here. We have fx equal to 1/2 times x minus 5 squared plus 2. This is a vertex form. All right. The vertex form in here, you guys should remember is a times x plus h minus k, right? Square. Right? You see, you remember from the vertex form of minus h plus k, sorry. Minus h plus k. Minus h plus k. Okay. So the vertex was is h comma k. Okay. Which is in this column is 5 and 2. Right? See that? 5 and 2. Okay. So also I have a equals to 1/2, which is greater than 0. That's giving me the graph is the graph opens upward. Right? So it opens upward. And and wider than and wider than y equal to x squared, right? Because you remember the a squared, right? A in here is I mean a so I'm gonna say because absolute value of a in here is less than 1, greater than 0. Gonna be okay. So okay. So let's describe our transformation associated with this graph. Okay, so we're gonna firstly, what we do is we're gonna shift. So step 1, shift y1 equal to x squared right, finally and up to it. Okay, and up to it. So what is that look like? So this was here as the original one, y equal to x squared, right? A ship right, find it. 1, 2, 3, 4, 5. Here is 5. And then ship up 2 units. 1, 2. So let's use red color here. And I have, come on, man. Okay. So maybe one more time. Okay. So this is one that I have ship right, 5 units, and ship up 2 units. So that's going to give me a function as, what is that? Y equal to x minus 5 square, and then plus with 2. Yeah. However, I'm gonna say step 2, the graph y2 is wider than graph of y1. So I will make it wider. So I will make this wider, and like that. So that's going to give me y equal to 1/2 x minus 5 squared plus 2. Okay? Maybe easy. Okay? Like that. Okay, so now we know that the vertex in here, I'm going to say is 5 and 2. Vertex is 5 and 2. Let's move to B. Maybe I have to move B to the next page. Okay. For B, I have A in here is -3, which is less than 0. So then graph opens downward. Okay. Also, absolute value of A is equal to 3, which is greater than 1. So then graph is narrower than y equal to x squared. What else? And then vertex is h is here, k is here, right? 5 and 3. Oh, actually no. We have a minus h squared. That's okay. So different sides to be negative and negative, right? You convert it to be like equal to -3 times x minus a -5 square and then plus with a -3, something like that. Then you see k, h in here is -5, k is -3. Okay, so you will have step 1 is shift the graph y equal to x squared left, find it, right? Because you see that x plus 5, right? Left, find it, and 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 reflect it again, because I have a is negative, so and reflect it across the x-axis. So since a is less than 0, then you're just gonna reflect it across the x-axis. Okay. And what else? And then shifted downward per unit. So you have the original one is like this, y equals to x squared, right? I'm gonna shift left 5 units, right? 1, 2, 3, 4, 5. So here's 5, nearly 5, right? And reflect it. So okay, so let me put -5 here. Reflect it. And then shift down 3 units. 1, 2, 3. Here's 2. And then 3. That's too big. That's fine. So it's gonna be like this. And then what else? I will have um, step 2. The graph y2 is narrower than y1. So you need to make it narrower. So narrower. Okay. And it is y equal to -3x plus 5 square minus 3. Okay? And the vertex was 5 and 3. Okay. We done example number 3 and we move to example number 4, which is finding equation of parabola. So we want to find the vertex form of a parabola with a equal to 2 and vertex equal to -2, 1. So you should know that the the vertex form of a parabola is in y equal to a times x minus h plus a square and plus k. Okay. So in here we have a equal to 2 and h equal to -2, which is a x. H is, I'm gonna say h is a x value of the vertex, which equal to -2, and k is y value of vertex, which equal to 1. So you can easily write it as y equal to 2 times x minus h, which is -2, right? Square and plus k, which is 1. And that can be rewritten as 2 times x plus 2 square and plus 1. Okay. Remember that we want to convert. So this going to be done for the question that write the vertex form, right? However, we also want to express the equation in the form as ax squared plus bx plus c. So what I do is I have to expand, right? If you still remember, that the formula a plus b square equal to a square plus 2ab plus b square. Okay, then you can convert y equal to 2 x plus 2 square become x square plus 2ab, so 2 times x times 2, right? And then plus with b square, which is 2 square, and then plus 1. Okay, so now let's see, let's simplify. I have 2x squared plus 4x, 2 times x squared plus 5 plus 4, right? Plus 1, right? And then distribution. Right? I have 2x squared plus 8x plus 8 plus 1. And that will give me 2x squared plus 8x plus 9 as the answer for this question. Okay. So another problem in here is using the vertex form to write the vertex form. Using the vertex formula to write the vertex form. So we want to find the vertex on the graph here and then write the equation in the vertex form. Okay, easily. Last in previous session, I have shown you the how to find vertex form, right? So it was x of v will equal to negative b over 2a, right? So remember that I have to list out a equal to 3, b equal to 6, and c equal to 1 in here. So that gives me negative 6 over 2 times 3, which equal to negative 1. And y of the vertex will be f of negative 1, which equal to 3 times negative 1 square plus 6 times negative 1 plus 1. And then that will give me a negative 2. So remember that vertex is negative 1 and negative 2. We also in the format h and k, if I write, so then h is going to be negative 1, k equal to negative 2. And we have the form as the vertex form as y equal to a and x minus h squared plus k, right? Then I can substitute a equal to 3, x minus h was negative 1 square, and then plus k is a negative 2, right? And if I want to simplify, then I have y equal to 3 times x plus 1 square minus 2 as the answer for the vertex form. Okay, so let's go to example number 6, writing the vertex form by completing the square. So I mean, like, you can go back the way that's using the vertex formula if you feel that easier. But today I'm also going to show you by writing the vertex form by completing the square. So so in order to write in the vertex by completing the square, you will try to start with y equal to x squared plus 4x first, right? And what you do is now is you're gonna add with a b over 2 squared. So let's go back to the way over here. You can see adding and subtracting BO2 squared. See that? So what is BO2? So in here I have another B equal to 4, right? So then B over 2 is 2. And B over 2 square is 4. Okay, so I add with B over 2 square, which is 4, and then minus with 4, right? So add, because you add something, you subtract something, then it will not change. This is just 0, see that? It's just 0. But why I have to do that? Because I try to make a completing square. Add and subtract 4 on the right. Right? Then if you look at the part x squared plus 4x plus 4 is actually can be converted to be y equal to x plus 2 squared minus 4. Okay, so here it's been what? It means x plus bo2 everything squared. Right? Chain it to the 4. To the change to the perfect square trinomial. Okay, so now you are having the vertex form is y equal to x plus 2 square minus 4, and vertex is -2 and -4. Okay, and 2 and -4. So remember that's remember that it was negative h plus k, right? So we have to change the sign for minus h and plus k, right? We have to change the sign for h, but the k is stable. Okay. Now let's move to number 7. Writing the vertex form. Right. So we want to write each equation in vertex form. Again, I will let you go by either way, from example 5 or 6. You can go either way, whatever you like to make it become vertex form. But I know that seems from the previous session you will go by number 5 easily, so I will show you by completing square wave, and I hope you will enjoy with this. So in here for this problem, you list out b, what is that equal to negative 6, right? Then you have b over 2 is negative 3, and you have b over 2 squared will be negative 3 squared, will equal to 9. So what does that mean? You will have to do adding and subtract 9 on the right side. So y equal to x squared minus 6x, and then you adding 9 and then minus 9 and minus 1. See that? And I'm adding 9 and minus 9 on the right side. Okay, because now I can have this group become perfect square trinomial. And the perfect square trinomial is in the form as, x minus b over 2 square, which is x plus b over 2 square, which is x minus 3 everything square. Okay. So I'm going to change this become y equal to x minus 3 square and minus 10. See that? X minus 3 square. And this is a vertex form. And the vertex is three and comma negative 10. Okay. So here's the answer. Similarly, for this one, I have b equal to 4, right? Then b over 2 is 2, right? Then b over 2 equal to 2 square, which is square, equal to 4. And also, I can have the perfect form, perfect square form is x plus b over 2 square, which is x plus 2, everything square. And now let's write out y equal to oh, wait a second. I forgot one thing. I have to, let me see. Okay, so there's a mistake that I made over here. I have to convert this because there's a equal to 2 in here. I want to change it to become only 1, right? So what I do, I have to delete this first, and I convert this to be in the format, 2 times with x squared plus 2x and minus 1. I factor out with 2 for the first 2 terms. So now I try to convert this guy to become a completing square. Okay, so how can I do that? I have to know that b in here is what? 2. Then b over 2 is 1, and b over 2 square is 1 also. And the form as x plus b over 2 square will be x plus 1 square. And now I will have adding and subtracting with b over 2 square inside the parentheses. So I have 2 times x squared plus 2x, adding 1, subtract 1, minus 1 outside here. But I will have to distribute this negative 2 out because I just want to use only to read this term to make it completing square. So I have y equal to 2 times x squared plus 2x plus 1 minus 2 and minus 1. See that? And then now you can convert it, become y equal to 2 times x plus 1 squared minus 3 after computing after vertex form. And vertex is -1, -3. So for this problem, I would say maybe you can think about the way using the vertex formula to find the vertex form. Right? So either way, but anyway, today I just show you how to use the completing square in a translation form for graphing the quadratic equation. And I will see you in the 11.3 later. Bye.